Good morning to all. In today's class, in the design analysis of algorithm, we are going to see the topic on fundamentals of algorithmic problem solving and important problem types. In previous class, we came to know that what is an algorithm and what are all the characteristics of an algorithm and how to write an algorithm with an example. So algorithm is nothing but it is a step-by-step procedures to solve a particular task. In today's class, we are going to see about what are all the fundamental aspects for any problem solving technique and what are all the important problem types. Suppose the time permits, we can see the important problem types also. So first we will see that what is a fundamental algorithm problem solving. So it is consists of 6 phases, 6 steps process. In the fundamentals of problem solving, first we have to understand the problem, and based upon the understand, we have to make the decision on particular problem based on some factors. After that, we have to design an algorithm and prove the correctness of an algorithm. After proving the correctness, we have to analyze the algorithm, and finally we are going to code the algorithm. These are all the 6 fundamental aspects of any problem solving techniques. First we will see what is understanding the problems. So understand the problems means we have to know the problem, we have to define the problem effectively. So we have to find what is the important instance of the problem. For example, to solve the whether the given number is odd or even means we have to know that what is that what is the general procedure to solve whether to find whether the given number is odd or even. So we have to first understand the problem. Second step is we have to make the decision making on some factors. So the decision making means decision making on the capabilities of devices, our storage devices. So based upon whether we are using that machine is a random access machine, so that is we are going to use a sequential algorithm or the parallel algorithms. So what is the speed and memory of the computer systems, and also we have to make the decisions on whether our problem is given the exact or approximation solutions. So based upon that, we have to select an algorithm. And third point is we have to decide what type of data structures we are going to use to solve the particular problems. So we know that what's the data structures. Data structures is a memory space. It is a storage space to store any problem in the any data in the computer memory. So for any algorithm, we have to, for any problem solving, we have to first select what is the data structures. It is whether it is a stack or queue, or it is a tree data structures or graph data structures, depends upon the problem. We have to select the data structures for representing the data. So another important factor we should know about before making an algorithm. So what is the algorithm design techniques we are going to use? So the algorithm design techniques is the approach to solve a particular problem. It is algorithm design techniques. So in that algorithm design techniques, we have a different types of design techniques. One is the brute force techniques, other one is a divide and conquer and branch and bound technique. So next is graph solving problems. So based upon the problem and what is the solution to the problem, we have to select the algorithm. What is the algorithm design we are going to use? Suppose for example, binary search means in the binary search we are using the divide and conquer technique. So linear means we are going to use the linear programming. These are all the things we have to consider. Next, last one we have to find out. So these are all the decision we have to make before going to design an algorithm based upon the, so what is the storage space capabilities we are going to use, and what is the data structures, what is the algorithm design techniques we are going to use. Next is the specification of an algorithms. So we have a different methods for specifying an algorithms. There are three types of decision methods to specifying any algorithm. One is a natural language, other one is a pseudocode format, other one is a flowchart. So we know that what is a natural language is it is a normal English language. We are going to define an algorithm. So pseudocode format is nothing but it is a combination of a natural language and programming language. So in that pseudocode format, we can select the pseudocode format to represent the algorithm. The third specification is the flowchart. So flowchart is nothing but it's a graphical representation of an algorithm. It is a method of expressing the algorithm by using the some geometric shapes. For example, triangle, and we have a certain shapes for certain descriptions. So these are all the three methods we have to specify any algorithm. One is the pseudocode, other one is a natural language, other one is a flowchart. So next, last one, the fourth one is after specifying an algorithm, we have to prove the algorithm correctness. So once the algorithm has been specified, we have to prove the correctness of an algorithm. For example, consider the GCD, finding the GCD numbers. So the n value is increases and that should reaches the 0. That is the correct way we have to find the GCD of using the equilibrium distance. So after specifying any algorithm, we should prove the correctness of the algorithm. It's a very important one. So the fifth one is analyzing the algorithm. So the analyzing the algorithm is depends upon the two main factors. One is the time, other one is the space complexity. So what is the time efficiency means how fast the algorithm is runs in a particular amount of time. Next is the space efficiency, how much space that algorithm is occupied in how much memory is used to solve a particular problem. This is the two important factor for any problem solving technique for analyzing the algorithm: time efficiency and space efficiency. This is the fifth step we have for solving the particular problem, analyzing the algorithm. So finally, after analyzing, we are going to coding an algorithm. So the coding or implementation of an algorithm is done by a particular programming language. We have to decide which programming language we are going to select to run the corresponding algorithm. So it is a C, a C++, or Java. So it is very essential to write an optimized code to reduce the burden of a compiler. So we have to write the optimized code for implementation in the particular algorithm. So these are all the 6 important aspects for any problem solving techniques. One is first step is we have to understand the problem. We have to define the problem very clearly. The second step is we have to make the decision making on what the storage capabilities in our computer. Next, what is the data structure we are going to use, and whether our program is given whether our algorithm is provide the exact approximation solution, or our which type of algorithm using techniques we are used. So these are all the 4 main factors we have to consider for the decision making on a particular algorithm. The third step is that we have to specify the particular algorithm in terms of 3 ways, whether whether it is in the natural language or the pseudocode or the flowchart. So we have to decide. The fourth step is after specifying, we have to prove the correctness of the algorithm based upon the some factors. So next, fifth one is the algorithm analysis. So we have to analyze an algorithm based on the 2 main factors. One is the time and space complexity. So time is nothing but how fast that program is algorithm is runs in a computer, and the space is how much memory it occupies. So these are the 2 main factors is very important for analyzing the efficiency of an algorithm. Last one is we have to do the implementation. We have to code the algorithm. So for that we have to make decision on which programming language we are going to select to run the particular algorithm. So for that selection of a programming language, our code should be the optimized one. So that optimized one produces the better efficiency of a given program. So these are all the 6 important fundamental aspects of any problem solving techniques. So I hope that you are clear about today's topics. So what are all the 6 steps for solving the problem solving techniques? Thank you.